This is a video on predicting single replacement reactions, and at the end I will briefly discuss the net ionic reaction, how you find the net ionic reaction from your complete balanced chemical reaction. If you have not seen the video on net ionic reaction, you need to take a look at that first before you look at the rest of the video. At this time, you should have opened this link on how to predict single replacement reactions and the associated chart, which is called the activity series, or I call it the strength chart. And there is a link to two examples, one where the reaction does occur, and then scrolling down to one example where the reaction doesn't occur. So you should have all those open by now. So in the single replacement reaction, what you have, as you know from your chart that showed the 5 different types of chemical reactions, you have an element adding to a compound. Now this, at your level, this compound is always an ionic compound. So there's a cation and there's an anion, associated with the compound. So the question is, does a reaction occur or not? Well, for a single replacement reaction, the key is to look at the element, okay, and that's the first step you're going to do. It's under the steps. You need to try to figure out that element. When it becomes an ion, does it become a cation or does it become an anion? That's important because when you need to compare it to something, and what you do is you compare the element to the ion of the same type in the compound. That's when you use the activity series. For example, the first one where you have calcium plus magnesium nitrate, calcium will form a cation. So therefore, what you're going to compare is you're going to compare the calcium to the magnesium ion in the ionic compound. You're not going to compare the calcium to the nitrate. So what you do is you go to your activity series. So this is part of the second step. And you look at your activity series and you look for calcium and magnesium. And if you don't know what the little words in the middle column are, it's my cute way of writing increasing activity, meaning as you go up the chart, the activity of that material is greater than the activity of the materials below it. In essence, for our case, is your element must be higher up on the chart than the corresponding ion in the ionic compound. If it is, for instance, in this case, where calcium is higher on the chart than magnesium, then the reaction does occur. If it isn't, if the element isn't higher up on the chart or column than the corresponding ion in the ionic compound, then there is no reaction. So, for example, for the calcium, as we showed, the calcium is higher up on the chart than the magnesium. I call it, the calcium is stronger than the magnesium, therefore the calcium will rip the magnesium off of the nitrate, and that's the way the dancing comes in. And then the magnesium will come off as an element. So as you know, magnesium as an element comes in groups of 1, and it's a solid, as you know, have memorized. Plus, what's left is calcium ions in nitrate ions that produce a compound. And as you know, using your rules of compound forming, the calcium is a 2+ charge, and the nitrate's a 1- charge. So therefore, you need 1 calcium ion and 2 nitrate ions to produce calcium nitrate, the chemical formula. Then that compound is always, that ionic compound they form, is always aqueous until you learn the rules about what's aqueous and not in double replacement. Then you balance it. In this case, and this is, I actually drew it incorrectly. When you balance it, there are all ones in front, so therefore you should be putting the coefficient of 1 in front of everything, and you get points off if you don't do it. So I should get points off for doing this. I'll fix it by the time you look at it. I'll have fixed it. So that's what that would be the products that you make for the chemical reaction, since it does occur. Now what I'm going to do is I'm going to show you an example. Okay, so going to the example, I actually did, going to the top, this is an example of when a reaction does occur. And what I tell you is, if the reaction does occur, does not occur, please give me a one sentence. And if it does occur, please give me a balanced chemical reaction, including all the phases. So this is the example of what we just talked about. The calcium is higher than magnesium. The magnesium comes off as as basically just an element, and magnesium elements in group of 1. It's a solid because you know that. And then what I did down here is I showed you how the calcium ion and the nitrate ion come together to form calcium nitrate chemical formula. So this is the complete chemical reaction showing all the species, both species that are changing and the species that aren't changing, and it's also balanced. And as you can see, I put the ones in front, and like you're supposed to. Okay, I will get to the Net Ionic reaction in a second. So here's an example if the reaction doesn't occur. And as the direction says, if the reaction doesn't occur, please give me a one-sentence explanation of why it does not occur. So here we have magnesium reacting with calcium nitrate. As we looked at before, the magnesium isn't higher up on the chart as the calcium, so therefore there is no reaction. And what you need to say is you need to say that the fact that the magnesium is lower on the activity series than the calcium, therefore the chemical reaction does not occur. You could have said it the other way around. You could have said that the calcium, since it's when it's in the compound, is higher up on the chart than the magnesium that's the element, therefore the reaction doesn't, that would be activity series chart. Therefore the reaction doesn't occur. You could have said it either way, but that's what I'm looking for work, if the reaction doesn't occur. Now, if you have read the net or watched or understand how to determine a net ionic reaction from a balanced complete chemical reaction, then I show you how, the work you need to do to show the net ionic reaction for this single replacement reaction. As before, I'll just briefly explain it. You must have a balanced chemical reaction, complete chemical reaction. Balancing makes it easier to understand. So what you do there is the next line, you want to break anything that is aqueous up into its ions. Well, calcium, the solid, isn't aqueous, so you simply rewrite it. So you take here, you rewrite it down there, plus magnesium nitrate is aqueous. So what are the ions in magnesium nitrate? Well, in the solution of magnesium nitrate, there is no magnesium nitrate. It is full of magnesium ions and nitrate ions. Well, as you know, in one compound, magnesium nitrate compound, there's one magnesium ion. And since there's only one of them, that's why there's one here. I'm sorry, here. But just like that, in this one compound here, there are two nitrate ions. And since there's only one of them, there are two nitrate ions. And then you do the same over here. Magnesium is not aqueous, so we write it. Then calcium nitrate is aqueous, so you break it up into the ions. Calcium 2 plus, and NO3 1 minus. And how many there are? Well, again, there's only one of these and one of these, and there's only one compound here in the chemical reaction. There's one, and then there's a 2 here. Very important is you must have, if you want ions or show ions, you must have charges. Leaving these charges out means the fact that you think you're telling somebody that it's a calcium element in a compound NO3. There is no compound NO3, and you mean ions, so you must put the ion charges in. Then what you do is you look and see if, make pretend that chemical formula symbol is an equal sign. You look for anything exactly the same on each side, and in this case, the nitrates. You would never have nitrates that would be a 3 here and a 2 there. That doesn't exist because of the balancing effect. So therefore, if it is, you go back and check. So these two are the same, so you put a line through it, meaning the fact that they are what are called spectator ions, and they are just watching the reaction, and they're not doing anything in the reaction. So you cross those out, and then you rewrite everything else that still is not crossed out, and this is a net ionic reaction. And for this one, what it means is that the calcium salt element is releasing 2 electrons, and the magnesium ion is gaining those 2 electrons to form the magnesium salt. So I hope this helps you in understanding how to determine single replacement reactions and predicting. Thank you.